Imperial Calendar, a cosmic masterpiece. The Imperial Calendar, intricately designed with 5 distinct layers, unveils a cosmic wonder at its core. Its central map showcases patterns of fixed stars visible from Earth, beautifully arranged into 3 concentric celestial circles. Middle circle displays the 12 zodiac constellations, forming the fundamental framework of the cosmos. Inner circle features fixed stars and constellations near the north celestial pole, systematically organized. Beginning with Polaris and Ursa Minor, the sequence moves to Hercules, Vega and Lyra, and Cepheus. Outer circle captures prominent southern hemisphere constellations, including Orion, Hydra, Centaurus, and more. These constellations are fixed on the main layer of the calendar, serving as an unchanging reference. Around this central plate, dynamic layers rotate, revealing the intricate mechanics of celestial motion. Between the stars of the zodiac belt and those in the southern hemisphere lies a system of divisions spanning 1 to 36 degrees, evenly distributed across the 360-degree celestial circle. Each degree corresponds to 612 Earth years, and collectively, the 36 degrees represent a total of 22,032 Earth years. Each degree is further divided into 4 equal parts, with each segment encompassing 153 Earth years. These divisions are again subdivided into smaller degrees, each representing 51 Earth years. Thus, within this 360-degree circle, every 51 years, we advance the second page of the Imperial Calendar by 1 degree. This gradual adjustment allows us to record the subtle changes occurring in the constellations around us during this epoch. A unique sky map perspective. One of the most fascinating aspects of this celestial map is the reversed depiction of constellations. Unlike our view from Earth, these constellations are mirrored. This inversion is intentional, designed to simulate the perspective of viewing the stars from outside space, rather than from our earthly vantage point. Thus, the constellations we observe in the night sky are flipped to align with the perspective displayed on this map. The Imperial Calendar serves as a timeless bridge between ancient celestial wisdom and modern cosmic understanding, offering humanity an extraordinary lens through which to view the universe. The second layer of the Imperial Calendar. The second layer of the Imperial Calendar presents a captivating visual of the days and months of the year. Arranged in a circular layout, this calendar integrates 2 key systems, the Gregorian and solar calendars. Beyond this, the outermost ring is divided into 34 equal degrees, representing orbital patterns. Each of these 34 degrees is marked within a triangular shape, with the tip of the triangle serving as an indicator. Each degree of rotation represents a 10.58-degree shift in the orbital movement of Earth's 18-year cycle around the Sun. This precise rotation influences solar and lunar eclipses, causing their occurrence to shift by 10 to 11 days in each 18-year cycle. Opposite the tip of each triangle within the 34 orbital groups, numbers ranging from 1 to 8 or 1 to 9 appear in alternating colors unique to each number. These numbers repeat twice, making up a total of 34, evenly distributed among the groups. Directly below the numbers 1 to 34 lies a secondary circle containing numbers placed at specific positions. These numbers, like the previous ones, range from 1 to 8 red and 1 to 9 blue, and are distributed at varying intervals along the circle's orbital path. The initial numbers from 1 to 8 and 1 to 9 are used to locate the positions of these secondary numbers. These markers are crucial as they indicate the hazardous zones Earth traverses, especially during solar activity. When the numbers reach their maximum, 8 and 9, they signify periods of intense and potentially catastrophic solar activity, necessitating preparedness in advance. This calendar beautifully anticipates such events. The central circle and orbital dynamics. In the innermost circle of this layer, the Earth's orbit around the Sun is illustrated 18 times, correlating with numbers 1 to 18 from page 5 of the calendar. There are additional significant shapes on this second layer, which are beyond the scope of this discussion for brevity. Discovering the North Star of each era. One remarkable feature of this layer is its ability to locate the North Star for any given era. Represented by the letter N, the position of the North Star changes over time due to Earth's axial precession. By rotating this calendar layer over the fixed primary layer, the calendar pinpoints the North Star's position for any specific period. Since the circle of the North Star is not centered on the main layer of the calendar, its position requires gradual adjustments over time. To account for this, The second layer rotates 1 degree clockwise on the fixed base every 51 years. This adjustment aligns with the celestial sphere's gradual shifts, ensuring accurate tracking of the North Star's location. On a larger scale, the calendar calculates the North Star's movement over the 36-degree celestial circle. To shift the North Star's position by 1 degree, the 153-year cycle is repeated 4 times, amounting to 612 years. During this period, the North Star's position advances by 1 degree, aligning with Earth's axial precession. Currently, Polaris, in the constellation Ursa Minor, serves as our North Star. Earth's axis, tilted at 23.5 degrees, completes a full circular motion across the celestial sphere over 22,032 years. This motion alters the North Star's position over millennia. Using the Imperial Calendar, identifying the North Star for any era becomes a seamless process. The outer circle and the dynamics of time. On the outermost circle of the second layer, the circle is divided into 4 equal parts. 2 lines intersect at a 90-degree angle, with the upper line passing through triangle 34 and the lower line through triangle 17. The middle line intersects the other at a 90-degree angle, passing through triangles 9 and 26. Outside the circle, at the 90-degree angle, a pointer called era is located on the right-hand side of the image. As this layer rotates, it aligns with the zodiac belt on the first layer, marking the position of each era. During spring in the northern hemisphere, as we observe the constellations, the sun is positioned within a constellation corresponding to the current era. By rotating this layer over the second page, every 51 years, both the North Star and the zodiac belt shift by 1 degree of their 360-degree orbital motion around the central black hole, known as A-hole, situated at the center of the constellations on the first calendar page. The northern and southern star belts lie in front and behind this black hole, respectively, while the Sun and Earth, influenced by 2 closer black holes, orbit it in a harmonious spiral motion. An intriguing aspect of this layer is the 23.5-degree angle between the line drawn toward the North Star and the perpendicular line passing through this layer. This angle causes the Sun to appear 23.5 degrees higher than the constellations during spring in the northern hemisphere. This alignment, marked by an equal line, enables precise identification of the Sun's position among the constellations. Solar activity and time measurement. Additionally, this circle records Earth's variable day and night hours, allowing for the calculation of daily light and darkness durations throughout the year. With its meticulous design, the Imperial Calendar transforms into a powerful tool for tracking celestial movements and understanding cosmic dynamics. This bridge between ancient wisdom and modern precision unveils the intricate dance of time, stars, and the universe. Calendar page 3. This page represents Earth's position, with the 24 hours of day and night prominently displayed at the center of the circle. On the outer orbit, the various crescent phases of the Moon, numbered from 1 to 29.535 days of the lunar month, are arranged in a circular sequence. Only on one side of the circle is the image of the Sun paired with the depiction of a total solar eclipse, where the Sun and Moon align perfectly. The 4 cardinal directions, north, south, east, and west, are also clearly marked. Calendar page 4. This page outlines the months of the year, divided into 12 lunar months of 29.535 days, plus an additional axial rotation of 10.58 degrees that accumulates over 18 years, summing up to a total of 365 days in a year. Thus, the months of the year are divided into 365 days, with various phases of the Moon arranged in a perfect circular ring. This allows the position of the Moon to be tracked or identified by utilizing all the calendar pages. 29.535 times 12 is equal to 354.42. 354.42 plus 10.58 is equal to 365. Calendar page 5. This page documents the occurrence of solar eclipses, which happen twice each year, within an 18-year cycle. Small circles in 4 different colors are used to mark these events. The numbers 1 to 10 are arranged in green, followed by numbers 11 to 18 in blue, forming half of the circular diagram. The sequence then repeats, with the number 11 restarting at the top of the circle alongside the previous numbers. Similarly, in the other half of the circle, yellow is used for numbers 1 to 10, and red for numbers 11 to 18. These represent the timing of solar eclipses each year, occurring twice on opposite sides of Earth's orbit. Each pair of colored groups expands symmetrically around the full circle, allowing for easy identification of the two eclipses occurring every year. Each eclipse falls within one of the two semicircles. Additionally, within the larger colored circles, there is a smaller inner circle divided equally into 360 degrees and labeled with numbers 1 to 18. This circle coordinates with the other calendar pages to illustrate its function. Alongside these figures, an elliptical orbit of Earth with the Moon is depicted, which can be used to measure and determine the size and visibility of the Moon from Earth. Calendar page 6. The final page contains a single dial-like pointer, designed for precision and calibration in measurements. This design seamlessly integrates celestial movements and cycles into a cohesive and visually compelling calendar system, perfect for narrating the story of cosmic phenomena and the intricate connections between time, space, and the Earth's place in the universe. A multifaceted mechanism. The rotating layers of the calendar represent the Sun, Earth, Moon, and 3 axial rotations governed by black holes. These rotations enable precise predictions of solar and lunar eclipses, seasonal variations, wet and dry cycles, solar flares in their 10 to 11-year cycles, megasolar flares or CMEs, coronal mass ejections, occurring approximately every 153 years, polar shifts, marking warm and cold cycles in 12,000-year intervals. By aligning these dynamic layers with the fixed central stars, the calendar becomes an unparalleled tool for pinpointing the timing and location of these cosmic events. The foundation of the Imperial Calendar, tracking solar and lunar eclipses across centuries. Before unveiling the Imperial Calendar, we first compile a comprehensive list of years alongside the occurrences of solar and lunar eclipses. It is important to note that the historical dates of all solar eclipses referenced in this work have been sourced from NASA's official website via the following link. Organizing the years. To begin, the years are grouped into 18-year cycles, divided into 34 distinct categories, covering a total span of 612 years. This structured grouping allows us to systematically track the eclipses that occur within this extended time frame. Since the year 2020 marks the starting point of the 34-category list, it is placed in Group 1. Consequently, the year 2019 falls into Group 34, representing the last year of the previous cycle and completing the 612-year rotation. Numbering the years within groups. Each year in the list is assigned a sequential number from 1 to 18 within its respective group. For instance, the year 2020 corresponds to January 1st, Group 1, Year 1, on the list, and the year 2024 aligns with January 5th, Group 1, Year 5. By arranging the years alongside fixed numbers from 1 to 18 within the 34 groups, the associated numerical identifiers for any given year can easily be determined. The utility of the Imperial Calendar. With this organization, the Imperial Calendar becomes a powerful tool. For example, the year 2024, labeled as 1/5, not only indicates its position in the grouping, but also provides insight into the solar eclipses associated with that year. The system extends to represent the maximum span of 612 years, where the final year in the cycle is labeled as 18/34, Group 34, Year 18. This arrangement encapsulates all solar eclipses occurring during this vast period, providing an intuitive and efficient method to identify and analyze celestial events. Unlocking the celestial masterpiece, using the Imperial Calendar to align with the cosmos. Step-by-step guide to aligning the Imperial Calendar. Initial setup, synchronizing the ages. To utilize this global masterpiece, we begin by overlaying the various calendar pages and aligning them. First, the second page is adjusted to match the current era. Since we are at the dawn of the age of Aquarius, the pointer on the circular second page is aligned with the number 9 of the 36 degrees on the first page. Aligning eclipses, page 5 and page 2. Next, we align the fifth page, which represents the solar eclipses in 18-year Earth cycles, with the second page. The arrow near the number 1 on the fifth page is adjusted to one of the numerical divisions of the 34 groups shown in triangles on the second page. Since we are in Group 1 of the 34 groups, the alignment is made with the number 1 of this group. Fine-tuning with the sixth page. Before adjusting the fourth page, the pointer on the sixth page is needed for calibration. Using this pointer, the eclipses of the year are set. For example, since the year 2024 corresponds to Group 1, number 5, the pointer on the 6th page is aligned with the number 5 on the 5th page. Then, the 4th page, which depicts the phases of lunar eclipses, is precisely adjusted using the tip of the arrow on the 6th page to match the full lunar eclipse display, configuring the 3rd page. Finally, the 3rd page, representing Earth's rotation and the Sun's movement alongside various lunar phases in a 29.535-day cycle, is configured. Given that the film's release date is December 23, 2024, the arrow on the central circle of this page is set to align with December 23 as shown on the 2nd page. With this simple adjustment, the celestial map for that specific day is revealed. Observing the night sky on this date will show the moon in its 23rd position on the 3rd page, appearing as a crescent illuminated halfway and positioned among the stars of Virgo. Observing celestial alignments. By referring to the 24-hour divisions on the 3rd page, which represent Earth's hours, the constellations visible in 24 sky points above the observer's location throughout the day and night can be identified. On December 23, 24, and 25, observing the sky at 6 a.m. reveals a fascinating alignment, drawing a straight line through the 3 stars of Orion's belt, known as the 3 Kings or 3 Magi, towards Sirius in the constellation Canis Major, and extending it further will pinpoint a location on Earth where the Sun rises precisely along this line. On December 26th, the Sun moves 1 degree from this trajectory, marking the seasonal shift. This phenomenon occurs differently in each hemisphere, with the Sun rising higher in the northern hemisphere and lower in the southern hemisphere, leading to longer days in one and shorter days in the other. The marvel of December 2024. One of the rare marvels revealed by the Imperial Calendar for December 2024 is that the days from December 1st to 29th align perfectly with the lunar cycle's 29.535-day orbit, starting on the same day and remaining synchronized throughout. This extraordinary event seldom occurs but will repeat in future cycles, offering another glimpse into the cosmic precision of this celestial masterpiece. Decoding solar activity, the Imperial Calendar's role in tracking eclipses and solar flares. Streamlining yearly adjustments for eclipses and solar activity. This section focuses on efficiently aligning historical dates with yearly eclipses and identifying solar activity in 10 to 11-year cycles. By referencing Group 34 of the calendar and working backward, we can utilize the meticulously recorded data on eclipses, lunar phases, and solar flares. 1. Initial alignment of page 5 with Group 34. To begin, the arrow labeled 1 on page 5 is aligned with page 2, specifically the apex of the triangle representing Group 34. This ensures precise synchronization of the 18-year cycle within this group. 2. Synchronizing with page 3 and 4. After aligning the 5th page, we set page 3 to match number 11 on page 5. Subsequently, page 4 is adjusted to display the full solar eclipse. This configuration illustrates the phases of the Moon during the first 6 months of 2012 on one side of the semicircular orbit of the Earth relative to the Sun, while the remaining 6 months are depicted on the opposite side, as indicated by the number 11 beyond the semicircle on page 5. So in Group 34, the solar eclipses occurred in 2012, year 11/34 of the Imperial Calendar. These events were on May 20th to 21st, corresponding to number 11 in this group. By fine-tuning the pointer on page 6, we pinpoint the lunar eclipse of June 4th, 2012. This is achieved by aligning the midline indicator with the Gregorian and solar years on the calendar. By aligning page 3 with the number 11 on the opposite half of the meridian on page 5, and adjusting the shapes of the months accordingly on page 4, we can identify solar eclipses, as well as determine the arrangement of the remaining 6 months of the year. Notably, a solar eclipse occurred in 2012 during the Earth's other semicircular orbit around the Sun, on November 13th and 14th. 3. Navigating events of 2012. Using page 3, other events of 2012 can be effortlessly mapped by matching the days to their corresponding Gregorian or solar dates. While we won't delve into all the occurrences, it's noteworthy that 2012 marked a peak in solar flare activity, featuring extraordinary mega-solar flares surpassing previous years. 4. Interpreting Group 34's solar patterns. On page 2, Group 34's triangle features a prominent number 8, with a secondary blue 8 signifying excessive solar flare activity. As explained earlier, numbers 8 and 9 on the Imperial Calendar denote heightened solar eruptions due to interactions with central black holes or K-holes. 5. Understanding color-coded numerical groups. On page 2, within the inner circle, the blue number 8 is pivotal. The circle divides into 4 quadrants. Quadrants 1 and 3, groups 1 to 9, numbers 1 to 9 in blue. Quadrants 2 and 4, groups 27 to 34, numbers 1 to 8 in red. This pattern repeats across groups 10 to 17 and 18 to 26, alternating blue and red numerical progressions. 6. Solar activity peaks in 2012. A dual-colored line, blue and green, on page 3 intersects horizontally through the page's midpoint, marked by a vertical arrow for targeting. The blue number 8 aligns directly with this bicolored line, signifying an exceptional solar flare peak in 2012. This level of solar activity is unique to Group 34, as the group approaches its end. In 2012, solar flares exceeded usual thresholds, marking an extraordinary culmination of solar eruptions at the cycle's conclusion. By systematically adjusting the calendar's pages and utilizing the numerical and color-coded markers, we can unravel significant historical and cosmic patterns. The precision of the Imperial Calendar offers unparalleled insights into solar phenomena, eclipses, and celestial mechanics. Tracking secondary solar activity using page 6. On page 6, where 2 lines intersect vertically, the page is divided into 2 prominent angles, 40 degrees and 45 degrees. To determine the angle of rotation, the appropriate angle must be selected based on the orbital group. 45 degrees for 8 group orbits. 40 degrees for 9 group orbits. In 8 group orbits, the line at a 45-degree angle passing through the 18-year circular list on page 5 intersects one of the years in the 18-year cycle. The solar eclipse corresponding to this year occurs where the angle intersects the list. If the 45-degree deviation extends into the next 18-year list, it identifies only one solar peak within the current cycle. The rotational axis shifts the nearest apex black hole to the next list, distributing 2 solar activity events across consecutive 18-year periods. Looking at Group 34, after identifying the first period of solar activity in 2012, the 45-degree angle on page 6 falls after the number 18 on page 5. Therefore, solar activity occurs once within Group 34. Subsequent solar activities, occurring in cycles of 10 to 11 years, will be located in the next 18-group list. Tracking solar activity in Group 33. 1. Begin by aligning the tip of the arrow marked 1 on page 5 with the number 33 located in the triangle on page 2. Then, use the arrow on page 3 to adjust for the solar eclipse. 2. Next, organize the lunar eclipses from page 4. 3. For the year 7/33 of the Imperial Calendar, corresponding to 1990 CE, the middle line on page 3 passes through the Gregorian years listed on page 2, indicating that a solar eclipse occurred on January 26, 1990. 4. At the top of the triangle above the number 33 is the number 7. Using this, locate the secondary blue number 7 and align the arrow on page 6 with this number. The green and blue central line of page 3 corresponds with the blue 7, signifying that solar activity peaked during this year. Now, using the arrow and 45-degree angle on page 6. Since the number 7 is above Group 33, align the tip of the arrow on page 6 with the secondary blue 7. The vertical line on page 6 passes through the 7 years in the 18-year list on page 5 and simultaneously intersects the solar Earth orbital pattern on page 2. This line, with an angle of 180 plus 45 degrees, 225 degrees on page 6, precisely crosses the years of the 18-year orbit, indicating that solar activity peaked during the years 7 and 18 of the list, corresponding to 1990 and 2001 CE, respectively. Tracking solar activity in Group 32. 1. Begin by rotating page 2 1 degree counterclockwise to align all constellations in the zodiac belt by 1 degree. The North Star also shifts 1 degree backward from 360. 2. Start by aligning the tip of the arrow marked 1 on page 5 with the number 32 located in the triangle on page 2. Then, use the arrow on page 3 to adjust for the solar eclipse. 3. Organize the lunar eclipses from page 4. 4. For the year 4/32 of the Imperial Calendar, corresponding to 1969 CE, the middle line on page 3 passes through the Gregorian years listed on page 2, indicating that a solar eclipse occurred on March 18, 1969. At the top of the triangle above the number 32 is the number 6. Using this, locate the secondary blue number 6 and align the arrow on page 6 with this number. The central green and blue line on page 3 corresponds with the blue 6, indicating that solar activity peaked during this year. The line on page 6, at an angle of 180 plus 45 degrees 225 degrees, precisely crosses the years of the 15-year orbit, showing that solar activity peaked during the 4th and 15th years of the list, corresponding to the Gregorian years 1969 and 1980 CE, respectively. Tracking solar activity in Group 1 during the new 34 group cycle. Now, let us track the future using this imperial calendar. Begin by rotating page 2 by 1 degree counterclockwise and aligning it with the number 9 of the 36 degrees on page 1 to ensure all constellations within the zodiac belt are properly aligned. This will also align the North Star. Start by aligning the tip of the arrow marked 1 on page 5 with the number 1 located within the triangle on page 2. Then, use the arrow on page 3 to adjust for solar eclipses. Lunar eclipses should be organized using page 4. For the year May 1st in the Imperial Calendar, corresponding to 2024 CE, the central line of page 3 intersects the Gregorian years listed on page 2, indicating that a solar eclipse will occur on October 2nd, 2024. At the top of the triangle labeled with the number 1 is another 1. Using this number, locate the secondary red marker labeled 1 and align the opposing arrow on page 6 with this marker. The central green and blue lines on page 3 correspond to the red 1, indicating that solar activity peaks in this year. On page 6, the line at an angle of 180 degrees plus 40 degrees, 220 degrees, precisely intersects the orbital cycles of 5 and 15 to 16 years, showing that solar activity will peak in 2024 CE and again between 2034 and 2035 CE. It is important to note that the arrow on page 6 now operates in reverse for the new 1 to 9 group cycle compared to the previous 1 to 8 group cycle. This reversal is due to the orbital movement of K-hole. Consequently, solar activities for the next tracking phase should be calculated using the opposite direction of the arrow on page 6, with a 40 degrees adjustment. The grand finale of the Imperial Calendar movie. As time passes, this calendar gradually loses its precision in aligning solar and lunar eclipses with Gregorian years. To maintain accuracy, 2 minor adjustments every 51 years are recommended. However, the calendar's core mechanisms continue to function with remarkable precision. Over time, as the 18-year group cycles progress along their orbital paths, these cycles shift into new 18-year groups. Therefore, the colored semicircle numbers on page 5, which are used to track eclipses, must be periodically adjusted to align with the new era. Additionally, due to the rotation of the K-hole black hole axis within the calendar, it is advisable to reposition the circular blue and red number grids, used for 1 to 8 or 1 to 9 groupings, approximately 15 to 20 degrees every 153 years. To address this, future adjustments could involve rotating the secondary number circled by these degrees. This is why the imperial calendar does not include leap years, and these adjustments should account for eclipses every 51 years and solar activities every 153 years, seamlessly incorporating leap years into its grand design. This calendar, while reflecting the past with remarkable accuracy, is equally capable of predicting future events. It can even be used to understand and anticipate axial shifts of the Earth. I have revealed the grandeur of this extraordinary calendar to show you how, in just 5 simple steps, you can achieve your goal and witness all its wonders, both numerical and visual. You will see how, in only 5 moves, the calendar can reveal the timing of any transformation, including polar reversals, and even warn you when to be cautious. If you grasp the precision and magnificence of this calendar and find it valuable, I ask you to share this film with others. Encourage them to watch it patiently. I have written this film as simply as possible, yet it contains an abundance of profound information. Over time, with examples and repetition, the concepts will become clearer. This calendar is not just a tool, but a testament to human ingenuity and the harmony of the cosmos. If you see its value, let its legacy grow by sharing its wisdom. Together, we can unravel the mysteries of time and space, one calculation at a time.